So hey guys, good morning and welcome to my channel. So today I'm gonna present you the credit EDA case study. So let's have the introduction first. This is a case study um, that aims to apply the EDA in real business scenarios. So where the banking and the financial services, while lending their money, can recover their money in a quite well manner. So you can pause the video to just go through the business understandings here, and here we have four cases. Like when a client applies for a loan, there are four types of decisions to be taken by the client or the company or the banking services, you can say it. So the first one is the approved, the second is the cancelled, third is the refused, and fourth is the unused offer. So do have a look on these compounds. Just pause the video and have a look on it. So coming to the business objective of which it is. So um, here we can say it as that if a client has a difficulty paying their installments, or when taking a loan, or a risky application, what we can say is that when the money isn't coming back to the bank or the client or the company. So basically with the EDA we can easily assess which are the customers which are finding it difficult to repay, or or some of the customers which can easily repay the whole amount. We'll have a look on the business objectives here, and let's begin with the coding part. So the first thing what we have to do with the coding is to import to libraries NumPy, Pandas, Seaborn and Matplotlib. We have to import. Then then if there are some warnings or in the particular function when running the functions, then to ignore that we have to import the warnings also and give it an ignore filter. Then we have to read the first set of data, that's the application data. We have named it as a df app, and with the dot head function we can view the top 10 data. Same, we have a secondary data set, it's the previous application data. We have named it as a df pref, and with the dot head function you can clearly view the top 10. Now to view the total rows and columns of the both dataset, we have to use the dot shape function. You can clearly see that there are about 3 lakh rows and 122 columns in the df app application dataset, and about 16 lakh rows and 37 columns in the previous application. Now comes the first part, that's the data cleaning on application dataset, the first dataset. With the dot describe function we can describe each numerical field, and the dot describe function views the count, mean, 25, 50, 75% of the numerical data sets. If we want to view all the columns present in the particular data set, then we have to use the dot column functions. So clearly you can see here we have used the dot columns function. Now we have to check for the null values. For this you have to clearly use the isNull dot sum function, and with that you'll definitely get all the null values in a numerical format. But it is not recommended to view the uh, view the view the null values in a numerical format. So it is best viewed when it is in a percentages. So here we have used as around a formula, or to just convert the numerical data to the percentage data. The first thing that I want to tell you is that you can feel like if you want to view the particular that this particular code, you Definitely, if you feel like you want to definitely view the code, you can simply just pause it and have a look on the dataset. So here you can see that it has an around 66% of missing values. Same goes with the other columns what we have here. On average there is about 50 to 60% of data is missing here. Here there are only 13% values are missing. Now the total number of columns what we have here are, you can view it with the dot length with the len function. It's 122. Now so we have now decided to remove the null values which are more than 90% in the data set. So we can clearly remove that with the dot log function and this thing. With the help of the dot log, it will only retain those values which are more which are lesser than 19% to the df app, and rest all will be dropped or ignored, what you can say it as. Then after ignoring or after the removal of the null values which are more than 19%, there are only 71 columns are left. So with that 71 columns we can start analyzing those, checking the data again with this function. So the data cleaning on the application dataset is done. Now coming to the data cleaning on the previous application dataset, I recommend you to just do this procedure by your own. It's very simple. The one thing you have to do is just to change the df pref thing, and that's all. Here we can see when we convert it into the percentages. Here we have 50% of data is missing. Here we have around 100% of data is missing. So it's better to remove those columns and not consider that. So from here we can clearly see that we can set an average of about 20%. So by removing the 20% of the null values, it is better recommended that. So the same procedure what we used in the application data set is, with the help of the dot log function, we will only store those values which are lesser than 20% of null values. So there will be only 23 columns left. Now the important part comes. That's the second part, is the imputing the missing values. So the first missing value what we have here is the name type suit in the name type suit column. So though it is a categorical column, so we have to use the value counts function. So with the help of the value counts function, you can clearly see that there are many numbers of unaccompanied. So we have to replace those values, or replace the missing values with the help with the unaccompanied, as the unaccompanied has more data relative to the other categorical columns. So by simply using the not fill any function, you can replace those values here, and checking the mean value here for the numerical column. We have to replace those values with the mean data only. So you can use the dot mean function on a numerical column. So though it is a numerical column, we have used the dot mean function here. So the dot mean function becomes this thing. So you can clearly see with from the description part is that filling the empty request credit bureau hour, and this other columns that are numerical with 0 as most of, the mean is around 0. So we have to fill those columns with those missing values with the 0. So you can clearly see that. You can use the .log function again here, and with the help of the fill NA you can clearly fill with the 0. Okay, now checking with the AMT goods price. So by checking the mean, it is not 0, so we can't fill the null values with the 0, so we have to fill it with the mean value. What we have done here is this. You can simply pause the video and just have a knowledge on this. You can also apply the same function with the AMT annuity. It is recommended for each and every numerical column that you should replace the null values with the .mean function. Okay, once we are done with the filling the null values, we have to recheck all the data, if there are any null values present in the whole data set. So by rechecking with the percentage formula that I have shown above. If you are not getting anything, just simply comment down below. I will explain it in the next video. No issues. Yes, there are some missing values. We can see it's 0.1, 0.21, 0.33, 0.33. So I think we can ignore it. It's better to ignore that. It's very less compared to the total value of the data. There are about 3 lakhs data once I remembered. Okay, now checking the data types of the column. With the .info function, you can clearly check the data type. Now, converting those data types, which should not be a float data type. With the as type function, you can clearly change all the float to int. Like the days registration, you can clearly see it from here. Days registration is float, so we have to change it to int 64, as days can't be in decimal format. Removing the unwanted columns here. So here are some of the unwanted columns we have to remove to do the analysis in a good format. So now checking the gender and the organization columns for any errors or any missing values. So here with the help of the .value counts function, you can clearly visualize the code thing, because code and organization comes under the categorical columns. So for the categorical columns, we have to use the .value counts function. So you can clearly see that the female is leading, and we have only 4 numbers of XNA, which we have to replace it with the female. So we have to use the .replace function to replace the XNA value with the F, or the female value. Here we have a confirmation. Next we are going on to the organization type. So here you can see there are about 55,000 values which are designated under XNA, so which is not acceptable, and we ultimately have to drop it. So with the help of the .drop function, you can clearly drop the XNA, and you can refer to this as well for understanding the logic behind the .drop function. So with the .log function, it will point out to only the organization type column and inside which XNA it is, and we have to remove that thing only. So here is a confirmation of the thing that the XNA has been removed completely. Now we have to create some bins for the income total and credit. So basically the bins you can see is having 25,000 difference of the 25,000 we have taken it here. So basically you have to uh, we have to distribute the incomes between these 0 to 25,000, 25 to 50,000. So these are the slots what we have created here, and these are the bins what we have created out here with the 25,000 difference. Same same we have to do it with the AMT credit, but it is with the it's a bigger gap. You can see it's a 50,000 gap. You have to create the bins and also the slots here out here, and with the dot cut function you have to include it inside the I mean um, this new column what we are creating here, and here you can see the bins income. I mean it's taking out from here the bins and labeling the slot incomes inside this. So it is what a dot cut function is used. Same here, same goes with here. Okay, now for taking forward checking for the imbalance ratio if we have any. So clearly you can see there is imbalance ratio. It's a 0 and 1. So here the target 0 means the people who are non-defaulters, and the target 1 means people who are defaulters. So we have to differentiate between them. For that we need to plot we need to plot like this. So you can just use a bar plot for this, or a bar graph for this. So here we have used simply dot plot bar h with a color green. You can choose any color you want. If you want to choose a red, black, or blue, you can choose it from here. With the dot title function you have to just mention the title, and also these are some of the label things you have to consider for this and this. Now here we are checking the imbalance ratio with a percentage, not a percentage, the decimal form. So we have an imbalance ratio of 10.55. Now doing the univariate analysis, the most important part of this video is the univariate analysis. So you can just simply refer to this. This is a count plot we have created here. Same goes for the income types here with the various genders. Now for the contract type with the various genders, we are mixing it with the genders so that we can easily identify which gender is leading for any contract type or something like that. Now we have a various organization types, so we are also using the count plot for this. You can feel like, if you feel like you are not getting, you can simply comment me, and if you want to just refer to any of these codes, you can simply just pause the video and have a look onto it. You will get an idea. So it's organization type, nothing to have here. Plotting those who are repaying the loan. So for that you require the income range and the codes. So here we have divided between the income range and the codes. So here are the income ranges, the bins what we have created, the slots although we have created here. So basically it describes the income ranges of male and female. So clearly we can see the more number of credits have been issued to 1 lakh to 2 lakh range. Okay, now taking forward to the various income types of the gender. So here we have income type and the code gender in the Y. So clearly you can see the working class and the commercial associate are leading the way. Now contract type, various genders, contract type. Here the contract type. Now again we are distributing the plots for the organization types. Now defining the correlation between the target zero people, which are the non-default people, what we have here. So you can do it with the ilog function, and .core function will definitely reveal the correlation between them. So you can plot a heat map for getting the correlation thing correct. So in heat map, the cross section is, it should be in a green or in only one format. Basically, the maximum value is 1, and here also you can see the diagonal have only 1 because they are the same column and the same row they are pointing out. These are the conclusions from the graph what we make here. Now doing the correlation among the target 1 people, those are defaulters. So quickly getting on to the heat maps. If you want to view the codes, any of the codes previous to that, you can simply backward the video to do it. The finding the top 10 correlations between them for the target 0. So with the help of the sort values, you can quickly refer this. These are the top 10 values what we require, and same is the case for the target 1. Here, another thing. Now comes the bivariate analysis of the numerical columns. So inside the bivariate columns, you know that there are two supporting columns required for any analysis. So here we are doing the income versus credit for target 0 and income versus credit for target 1. You can clearly see with the help of this scatter plot we have created out here the values for this. Now finding any correlations between the credit versus goods price for the targets 1 and target 0 people. Plotting this scatter plot. So now the next thing is the finding outliers. For the target 0 people, we have used a box plot here. Distribution of credit amount with the help of the box plot. Now distribution of annuity and amount with the help of the box plot. Those were for the target 0 people, and these are for the target 1. So first comes is the income amount distribution with the help of the box plot. Then distribution of credit amount, box plot. Then comes is the annuity amount, box plot. Now we have also a requirement for the multivariate analysis, where we require number of 3 numbers or more than 2 numbers of columns we require for to generate a report for that. So here we require a box plot to measure for the target 0 the education and their credit, also their family status, whether it's single, married, civil marriage, or something like that. You can simply refer the code here, and after that the graph has been generated out here. Plotting the block plot for the income amount, income versus education. Those were for the target 0, and these are for the target 1. There is a single change, that's it. I mean, just a single change on the data, the target 1. Yeah, that's it. Rest all is same. You can see it's for the target 1. I'm going a little bit fast. If you feel like if you are not getting anything, just pause the video and refer to these things. If you didn't get anything, just have a comment down below. Okay, now coming down to the previous application data set. We have completed our first data set out here, and now we are coming down to the previous application data set. Reading the data set, checking for the none values if any. Now checking the cash loan purpose. So here you can see there are two unknown columns, XAP and XMA. So we unfortunately have to drop those columns because the values are much more, and we can't replace it because we don't have any of the information for that. So with the drop function, we are clearly dropping an XAP. After dropping the values, you can clearly see our match. And now we are merging the two datasets with each other, the application dataset with the previous application. So with the help of the .merge function, you can clearly approach this. On the left hand side, you have to keep your DF app, that's the first one, application dataset. On the right, you have to keep your DF prev, and it should be on an inner join. Inner join means if both the columns have any, if both the columns have any, both the datasets have any common columns, they can simply match on those. Now renaming the columns, dropping some of the columns out here. Also performing a univariate analysis on both the datasets. Check with their contract status with their purposes. These are the contract status with the targets. Performing a bivariate analysis. Performing a bivariate analysis on the previous credit amount and housing type. So at last we have come to the end of this video. With the help of the conclusions, what we get around is the bank should approve more loans for the office apartment, cooperative apartment housing types, as there are less payment difficulties. Banks should provide loans to repairs and others purposes. Banks should provide loans to business entity type 3 because those are one of the fields that are topping the non-defaulters zone, so it's better to keep the non-defaulters primary thing. Working especially female employees are the best target for the loans. We have just matched that. Thank you for the patience of this video. To keep your patience for looking onto this particular video. Have a nice day, and do support. Press the like button if you liked the video. Thank you.